Okay, so we need to look at one of, I suppose, the last little aspects of our coordinate geometry of the line, which of course is making use of our coordinates, making use of the line. We've built a lot of kind of the kind of foundational stuff and kind of formulas and equations and all of these things. Now we simply want to be able to draw those lines. So we're looking at graphing the lines, putting them onto our coordinate plane. So the first type we're just going to look at very briefly is just lines that are parallel to the x and to the y axis. So if I have a line that is parallel through to the y axis, then that might be a line of the form x equals something. So like, for example, you can see here my blue and my green one, x equals -1 or x equals 3. These lines are just vertical lines. They're parallel to the y-axis. They follow the same kind of idea. And really, that's kind of all there is to it. Every point on this line, no matter where it is, will have a coordinate something, -1 something. Okay, -1 something. Same over here. Every point on the line would be 3 something, 3 something, 3 something. Okay, so these lines, I suppose, are important because their slopes are kind of different to how we have been looking at. So the slope of a vertical line there is just going to kind of come out as undefined. So it's kind of for you to recognize that if a line is passing through directly through coordinate on the x-axis and is parallel to the y-axis, a vertical line, then it's just going to have an equation of the form x equals a particular number. And in the same way then, a line that is horizontal is going to have an equation y equals something, and every point on that line will just have that y value of, for example, in this case, 3. So every point on this line would have a y value of 3 and an x value of whatever the corresponding x value is to where that coordinate is. Okay, so that I suppose is the first thing to note. So if we've any kind of vertical or horizontal lines, they're going to be of the form y equals something or x equals something. So they will have one coordinate variable within the equation there. If we look then more generally at graphing lines, if we want to draw the graph of a given line, we need to have 2 points. Okay, at least 2 points. And the easiest 2 points we can find are where it crosses the axes, so the x-axis and the y-axis. So just reminding ourselves of what do we know about those axes. So the first thing we have marked in red here is on the y-axis, x will always be equal to 0. This is the x-axis. This is the y-axis. Always think of starting here at 0, 0. Then if I wanted to move just upwards but not left or right, then the x part is going to remain 0. Okay, so on the y-axis, x will always be 0, and my coordinate then will just work out as being 0, y. So if I'm on the y-axis, x is 0, and I just get 0, y, I only have a y value. On the x-axis, I only have an x value. So it'll be x0 and there'll be no y value. I'm not moving up or down. So on each of the axes, the only coordinate or the only kind of the x or y part that is important is the one that corresponds with the axis. So on the x-axis, x equals, we have an x value and y is 0. On the y-axis, we have a y value and x is 0. So if I want to graph a line from the equation, I'm going to say, well, what happens if x is 0? Find out what the corresponding y value is. What happens if y is 0? Find out the corresponding x value, and then plot those two coordinates and connect them to graph my line. Okay, we can also remember then that slope-intercept form can give us that y-intercept a bit more quickly. So let's look at this in kind of an example here. Graph the equation of the line, or graph the line with equation 2x plus 3y equals 6. So let's look on the x-axis first. So on the x-axis, we have said that the point will have an x value, but will have no y value. So it will be of the form x0. So let's fill that in. So we're filling in an x value. My y value is 0. So I get 2x equals 6 and x equals 3. So immediately the point that I have here is the point 3, 0. If we look then at the y-axis, so on the y-axis, only the y coordinate is important, and the other coordinate can be 0. I suppose the key thing here is working out the value and then ensuring that we write the coordinate in the correct way. So seeing here how I do end up with two coordinates. It's not that I put those two values together, I don't combine them into one coordinate. I'm noting that what I'm looking at is a particular case where either x or y has a value of 0, and I'm looking for what is the corresponding x or y value that would go with that to give me an equation of to give me a point on that line. Okay, that's really all that I'm doing here. So I have an x value of 3 and a y value of 0, or I have an x value of 0 and a y value of 2 in this case. Okay, and let me see, I have the graph underneath here, so we'll just kind of look at it. So we can plot our 2 points, we can plot the point 0, 2, we can plot the point 3, 0, and we can connect the two of them up. Okay, so fairly straightforward once we just get to grips with all of this kind of talk about the axes. So remembering, on the x-axis only x is important, on the y-axis only y is important. The other coordinate, be it x or y, will just have a value of 0. So let's kind of apply that then to some of these example ones here. So looking at the first one, x equals 3 and y equals 4. I suppose this is a particular case like that first case that we were looking at here. So if I was to mark out maybe some of my axes here, I'm not going to need all of it, so I'm just going to mark out what I need. Well, in this case, for x equals 3 means that the line needs to go through this part here, and it's actually just going to be a vertical line through that coordinate there. Okay, similarly then y equals 4, horizontal line through this point here. Okay, so nice and straightforward, obviously using a ruler, drawing it out nice and kind of neatly there for us there. And we can put in a little maybe note of the lines, x equals 3. Looking then at some of these other examples, a bit more to do with this one, 3x plus 5y equals minus 15. So let's just look at the two cases here. The first case is on the x-axis, okay, or the first case, I suppose, on the x-axis we've said that only x is important, so that would be the coordinate x, 0. So let's fill that in. So that'll be 3x plus 0 equals minus 15, and that will give me that x equals minus 5. So I know the point minus 5, 0 is going to be on my line here. Then we could try the y-axis, and we said on the y-axis only y is important, so the other coordinate will be 0. So 0 plus 5y equals minus 15, which will mean y is minus 3. So the point 0, minus 3 is on my line. Okay, so putting all of this together then, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, 1, 2, 3, and minus 1, minus 2, minus 3. Okay, so let's kind of put all of this together then. The first point I have here is minus 5, 0. So that's actually going to be over here. We just need to make sure we mark it in. That's going to be this one here. And my other point is 0 minus 3, which is down here. And I can put that together. And let me see if my tools work here. Yeah, sometimes it sends me away off. But we get a good sense of the line there from connecting those 2 points up. Okay, and we can kind of keep that nice and neatly. I might just choose maybe then to just make the line just long enough so that I'm using those two, so that drawn between those 2 points. Okay, and I equally could extend it beyond those 2 points easily as well. Okay, so we can kind of see there, so from looking at our line, we could rearrange and kind of work out that we have a negative slope there, but we can obviously see it by observation there as well. Looking then at the other example we have here then as well, let's start off again with the x-axis, where we've said the x is the only one that's important, so the other coordinate is 0, so that's just minus 0 equals 8, so x equals 2. On the y-axis, only the y coordinate is important, so that's 0 minus 2y equals 8, so y equals minus 4. So my two coordinates, 0 minus 4 and 2, 0. And again, we can just label as before. Minus 1, minus 2, minus 3, 1, 2, 3, minus 1, minus 2, minus 3, minus 4, minus 5. So labeling my 2 points here, my point 2, 0 is going to go here, my point 0 minus 4 is going to go here, and I can connect those 2 points then with the line there to get my equation of the line. Okay, so really what we're seeing here and what we're kind of doing in all these steps really is looking for those two key points. So on the axis, reminding ourselves nearly using that phrase that we're using there. On the x-axis, only x is important. On the y-axis, only y is important. The other will have a value of 0. You should get 2 points by doing this. You need 2 points to draw the equation of a line. Okay, once we have those 2 points, we're able to sketch that equation of the line then. We could try and find other points, but we cannot be guaranteed what x values are going to work, because there may be x values for which we don't end up with a nice point that's easily plottable. Whereas on the axes, you're generally 9 times out of 10 going to end up with a nice point that you're easily able to plot, particularly, I suppose, in the ones that you would be given in questions. So just to be aware, and then even to kind of observe afterwards, to kind of adjust for slope, to maybe kind of ask yourself, is this a reasonable graph here? Does it fit with, do I know any other points on the graph? Can I check that those do still appear on that equation on the graph of the line? But yeah, so generally looking for those points on the axes where my equation cross, or where my graph will cross the axes, and then using that to draw those sketches.